Hey everyone. So what I wanted to do this morning over Zoom is to record a simple video here, just kind of walking you through what you would need to ultimately do with stat exercise number 2. And I'm going to do this for both Jamovi and PSPP in separate Zoom videos so that for those of you using the various platforms are able to follow along. So what I'm just going to do is scroll on down to the appropriate module where that's quant 1 and here's quant 2. So I'm just going to go ahead and download the files. So let me get the instructions. And it should download it. And then let me first go into PSPP and download that data set. So pardon the slow sort of computer connection this morning. Stat exercise 2, PSPP, and so by downloading this file from Canvas and not using any other previous versions I've got on my own personal computer here, we should have the exact same experience. So if I click over here, go to my download files, there are the two for stat exercise 2. So let me just open up the instructions, make sure everything is going to function properly. All right, so here is everything that I need to do. And then with PSPP, I've already got it opened, but here is one of those things that based on our previous 2 class sessions, that this has been an issue that's caused some crashing for people. So I just want to walk through how it seems to be PSPP and Jamovi's preferred way of opening files. Most files you see, it seems like you should just be able to double click here, but on Apple products in particular, that appeared to cause some crashing. So the way that I would open files is to use the old school kind of go and find it. So these are previous files that I've used, so I'm not going to open those because those are stored in different places, and I want to use the exact same file that you guys are using. So I go to File, Open. It's here in the Download folder, and so I should have the exact same file open that you ultimately have. And now with stat exercise 2, unlike the first one, I have not gone in and changed anything. So one of the things that you may want to do, just to make it easier and help yourself sort of understand what these various columns represent, is click over from data view over into the variable view. And now let's pull up the instructions here. Let's see if I can manage to make this a little smaller. Maybe not that small. Because what I ultimately want to do is be able to see this. And now here I know what the column is, so I can go in and relabel these. Location here, my value labels. One is San Jose, and that 2 is San Francisco. And I'm not going to go through all of these, but I will go through the column name at least so that I have an understanding of that. Variable 2 or column 2 is individual type. And so one of the things when you're labeling the variable name Typically, PSPP does not use spaces or special keys or anything like that. Sometimes, depending on the version you have, or the version of the software that you're using, it may not allow for multiple capital letters outside of that first letter. So just be aware of those type of issues. If you type lowercase everything, typically with short variable names, you should be fine. So let me just go get these labels over here. 1 is blue collar, 2 is white collar, 3 is undecided. 1 blue collar, 2 is white collar. And I believe this question asked about what type of volunteer work they were interested in. Decided, and you can see here that it did not like how I had labeled that. So individual type may have been too long. We'll just see. And so I'm just going to pause the video here while I go in and ultimately record or change the rest of the file names so that we can come back and work with this in a clearer, easier way. So I'm going to pause the recording now, and I'll be back shortly. All right, so we should be back recording now. I've gone through and made some changes here to the variables, provided some names. So let's go back over here to the data view, make sure everything's sort of stuck. I will say that for once you get to, I think it was column D through, what was that, D, E, F, G, H. D through H, because those are the Likert variable scales, I did not go in and change 1 is strongly disagree, 9 is strongly agree. Left those kind of as is, but I did make some changes here for gender, ethnicity, education, and then the first 3 that we kind of did together. So it's one of those things that as I was typing in education, certainly felt that there probably could have been some other categories. But keep in mind, this is the data set that we inherited, so this is what we're working with. And now I just want to go through stat exercise 2 with this revised PSPP data set. And let's just walk through how we got some of these answers. So I'm going to go back over here and open up the stat exercise number 2. And so the first question is to describe the composition of participants. This should include the 4 demographic variables: gender, race, education, and age, and 1 categorical, so looking at location here. And so central tendency, mean, standard deviation, mode, and median when appropriate. So let's go back over into PSPP and let's run the demographics here. So for the first one, I'm going to go to analyze. I want demographics. For my categorical variables, all I can use are basic frequencies. And so what I'm looking for here, it said it wanted location, it said it wanted gender, ethnicity, and education. Location is that sort of categorical variable. Age, let's go ahead and throw age over there too, just to see what it's going to wind up doing. Mean, I want standard deviation, minimum, maximum are fine, but mode is down here. And let me get median just to see what it says here. Frequency tables, always okay, we're good. And let's just go ahead and hit okay and see what the data output looks like. And it's gonna appear, at least in mine, and I pop under window. And so here we see the results. And I'm just gonna scroll through these pretty slowly. So here we got San Jose, San Francisco with location. And again, sort of you'll want to report the N, the frequency, that the N value is 172 for San Jose, 121 for San Francisco. You also want to report that as the percentage, so 58.7, 41.3. Because this is a categorical variable, so it's not an open-ended number. It's not a scale. All of these, even though it's calculated, I do not report the mean, mode, standard deviation, or median if it was an option in PSPP. I would not report that here for categoricals. So these two columns here for location, and you're essentially done with that particular variable. Going down, scrolling down a little bit to gender, it looks like there are about close to 2-to-1 females to males, so 186 females, 107 males, also reporting the percentage, 36.5, 63.5, and then again, once again, because it is a categorical variable, I don't need to worry with any of the measures of central tendency. So no mean, no mode, no standard deviation, no median. Don't need to worry with that there. All right, so let's, oh, there's the median. It's labeled slightly differently here in PSPP, but median there is 1 for location and then 2 for gender. All right, so let's look at ethnicity here. It's also a categorical variable. So I simply need to report the different categories, the frequency, and then also the percentage here. And so I'm going to leave that on the screen a little bit longer here since there's more groups. But those are the things that you would need to report for the categories. And again, that might be something like there were 54 African-American Black individuals who responded to the survey, and then in parentheses put 18.4%. Do something similar to that for all 7 categories. So now I'm going to scroll down. You're going to do something very similar to education. So it's close. The number of number of participants who had a high school diploma or had a graduate degree as their highest completed level of education were comparable. So N equals 25 for high school diploma, N equals 34 for graduate degree. Also going to report those parentheses, the percentages and parentheses following that. So again, there's the numbers there. For both race and education, much like gender and location, don't need to worry with mean and mode, standard deviation, and median because these are categories. This is not an open-ended sort of continuous variable. Age, however, is very different. Age is an open-ended variable here. So this is much like a scale question. So I do not, even though PSP was able to calculate it for us, I do not need you to go in and ultimately say there were 8 individuals who are 18 years old, 20 individuals who are 19. I don't need any of that for an open-ended or a scale type variable. So what you need to do here is scroll down to the age central measures of tendency option. And what you need to report is the mean age is 32.75 years old. The standard deviation is 14.11 years. And the mode is not provided here for some reason. And the median here is 25. I personally also would probably provide the minimum and maximum range, saying something like the youngest participant or the youngest respondent in this survey was 18. The eldest was 73 years of age. And so that should be able to walk you through the first question. And so I am going to close out this window now because that makes it a little easier with the data interpretation. So let me close that. I've still got my data set that I'm working for, but now let's jump back over to the instructions to look at question 2. To address the first research question, describe the participants' evaluation of the help volunteer sessions in terms of feeling ready to volunteer. And so that looks like it's column 4, column D here. Whether it was a good use of their time, so that's column 5 or column E. and whether their questions were answered. And so that is that following. So these three sort of here all in a row. And so to do that first part, what I want to do is go back over here to analyze. I want to look at descriptive statistics, and specifically this time I'm going to go to descriptives, pull that up, and I'm going to move felt ready. It was a good use of my time. My questions answered. I'm going to move that over. I want the mean. I want the standard deviation. I don't need minimum. I don't need maximum. All right, so we'll go with those and hit OK. And here's what we have. So this is just looking at the overall response to this question. And so with this question, 1 indicates strongly disagree, 9 indicates a strongly agree. And so for the question, I forget the exact wording, but after the training session, I felt ready. The mean score, the average was 7.3. The standard deviation was 1.96. Good use of time, 7.5. Standard deviation, 1.9. My questions were answered, 6.6. And a standard deviation of 2.18. Okay, so I'm reporting the average, I'm reporting the standard deviation on a question like that where I'm just giving the overall big picture. But if we jump back over to question 2, I now see next use an independent t-test to determine whether there was a difference between men and women. And so on these same variables that I used here, let me go back to the data set. And now I want to analyze, I'm going to compare means. I'm doing the independent samples t-test. My grouping variable is gender. I need to define the groups. So I want one group to be male, one group to be female, continue. And I have these 3 variables that I'm looking for, options, that is correct. And let's hit OK in that pop under window. Excuse me. We're now going to go back over here. And so I've got my felt ready. Males appear to be slightly less, though pretty close to females in terms of the session preparing them. Both likewise felt it was a good use of their time. And there's a little bit more distance here, and they felt that their questions were answered. But to really sort of analyze this, we need to go down to this next table. And so again, we can cross through the Levine's test for equality, because that's not what we're measuring here. What we're looking for, it really is these first 3 columns. And so the t-value, this first column here, really is the first thing that we're going to report. Small t-values indicate that there's no statistical significant difference. I'm sorry. No, that's correct. Small t-values mean that there's not going to be a statistical difference. Large t-values, the t-value ultimately helps measure how far apart the mean scores are. So when that t-value is high, you expect to see those mean scores very far apart from each other. Here we do have some relative small t-values, you know, -1.2, because we're working with the equal variances assumed, not that second line here. So we're looking at the first, -1.2 for felt ready, -1.07 for good use of time, and then -1.7 for questions answered. I want to report my t-value. I want to report my degrees of freedom, which for t-test is the number of cases, the number in the sample who answered that question. And here we see that is 293 individuals. So 293 minus the number of categories, male and female here. So 293 minus 2 is that 291 that we see here. And then our significance value is our p-value here in PSPP, and at 0.228 for felt ready, 0.288 for good use of time, and 0.09 for questions answered. None of them are statistically significant, though we could make a case if we wanted to be that touchy-feely sort of statistician that 0.09 did get a little bit close to 0.05, especially when we think about the 0.0001 to the 0.9999 possibility. 0.09 is not that far, but technically it is not statistically significant. Okay, so I would want to report in this case the mean scores for each of my two groups, as well as the standard deviation. So I might report that females and males felt similarly in feeling ready to volunteer after the training session. After the female, I would put in parentheses M equals 7.37, comma, SD equals 1.92, close of parentheses, and males, parentheses, M equals 7.08, comma, SD equals 2.03, close that parentheses, both felt similarly ready. And then I would follow that up with the t-test results. These average scores were not statistically significant based on an independent sample t-test. And then in parentheses there, I would have something t equals negative 1.21, comma, df equals 291, comma, p equals 0.228. And so I'm just trying to provide everything sort of in that text narrative, and then would do the same for good use of time, questions answered. Report the mean, report the standard deviation, and then report the t-test with the t-value, the degrees of freedom, as well as the significance. Okay, so I'm going to close this one out for that portion. So let me hit close here. Go back over to question 2, and it looks like there is an additional t-test for the second question. Also use an independent t-test to determine whether there was a difference between people who took the training session in San Jose and San Francisco. So we're still working with felt ready, good use of time, and questions, but now we're looking at location rather than gender. So I want to go back into analyze, compare means, down to independent sample. Whatever was previously there in my last test is still going to show up. So felt ready, good use of time, and questions are there, but now I need to move gender out and move location in. And so I still need to go define my locations, San Jose and San Francisco there. Everything else is good. My options still the same, continue that, hit okay. And it's interesting, sometimes it's a pop under, sometimes it's a pop up window. So kind of strange there. But much like the others with gender, I'm going to compare locations now. So I'm going to first talk about the mean scores, 7.4 for San Jose, 7.07 for San Francisco. Also report that standard deviation. And then I'm going to report on the equal variances assumed line. Again, not looking at Levine's test for equality, but here my t-value is going to be 1.47. My degrees of freedom is 291, and then p-value here is 0.143. So not significant for felt ready. Good use of time. Here we see a 0.4 difference in the mean scores for San Jose, San Francisco. We also report the standard deviation for both. And if we look down here on the equal variances assumed for good use of time, we get a little bit closer to that 0.05. But technically the 0.078 is not statistically significant. Still going to report the t-value and the degrees of freedom. Looking at questions answered here, I'm reporting my mean score for San Jose and San Francisco, also reporting those standard deviations. Get down here to the statistical tests, and for questions answered, looking at the equal variances assumed, my t-value is the lowest of all of them, and small t-values mean that it's not going to be statistically significant. So t equals 1.08, comma, df equals 291 for my degrees of freedom, comma, my p-value equals 0.281. So definitely not statistically significant there. So I'm going to leave it on the screen for just a little longer so you can compare your own answers. And then I'm going to close out this window and we'll move on to question number 3. All right, so back over to the instruction file. And so now we're moving on to the second research question here. And it examined whether volunteers felt as if they were important to the nonprofit. To answer this, describe the participants' evaluation of their work helping the organization, and whether they feel part of the organization based on the instructors. And so if I remember correctly, this particular question, we go back up here, we can see the exact wording. I understand how my work helps the organization. This is column G here. And then also I was made to feel part of the nonprofit by the instructors at the training session. So I'm working with these two, which I've labeled questions, understand helps and feels part of, to answer this third question here. So what it is looking to do is something very similar to what we just did. I'm reporting the overall values for the first part. Then I'm going to determine if there was a difference between men and women, and then finally look at the differences in the two offices. So I'm going to go over back to PSPP. I'm going to go to my descriptives here. And again, it's going to keep everything that I've previously done. And so now I just need to move the right variables over. So understand, help, and feel part of. Everything down here that should be is still connected or still chosen. So let's hit OK. And we can see that on that 1 to 9 scale, the volunteers feel part of the organization, certainly. A little bit less, but still favorable in how they view that their work ultimately helps the organization. So again, for both of these, the mean, the standard deviation are what I'm going to report. So let me just close this out because I want to go back over here now, and I'm going to compare the means with an independent samples t-test. And what I'm going to do is use understand how it helps and feels part of. And even though we're going to need location eventually, I just want to do these in the order that it asks for. So I'm going to look for males and females for those differences. Options will be fine. And so here I see that ultimately, 6.92 from the average score for females for understanding how it helps. Males are a little bit lower at 6.5. I report the standard deviation. Look at the equal variances assumed. Skipping the Levine's test for equality, I'm looking at my t-value of negative 1.57. My degrees of freedom, which is the number of participants, 293 total minus the number of groups that there were. So 293 minus 2 equals equals 291 here. And then I've got my p-value, which is the significance as it's labeled here. And that is 0.118. So no difference in 6.92 and 6.53 statistically. As part of feeling part of the nonprofit, look at the mean scores, and men are at 6.97 with a 2.11 standard deviation. Females are at 7.53, so a little bit higher. and a smaller standard deviation at 1.88. Go down here, skip Levine's, look at my t-test, we're getting a little higher, so negative 2.38, same degrees of freedom, because it's still the same number of people minus the same number of categories, but now we've got our first statistically significant finding. So 7.53 and 6.97, the mean scores for our men and women, is a statistically different, a statistically significant difference. So it's interesting here that essentially we have a 0.4 difference here and just a little bit higher at 0.5 for the second one. The first one was not a statistically significant finding, but the second one at that 0.5, ultimately I guess that's what, 0.56, is actually statistically significant. So again, for my t-tests on both of them, I report the t-value, the negative 1.57 for understand helps, the degrees of freedom, and the p-value. For feels part of, my t-value is negative 2.38, 291 for degrees of freedom, and p equals 0.018. Again, I'm working on the equal variances assumed line, skipping Levine's there. So let me close this out, and let's go do the same test for locations. So compare means to independent samples. My test variables are going to be the same. I'm moving gender out again, bringing location in, defining my groups, and continuing here. Hit OK, pop up the results. And so just based on the mean scores on these, I can see that there's not going to be any statistical significance. Both are very close on both of these. 0.07 difference, so very close here for understand how the work helps. 6.75 for San Jose, 6.82 for San Francisco. Similar standard deviations, and then 0.2 difference here for feeling part of the nonprofit. San Jose slightly higher at 7.41 to San Francisco's 7.21, and I also want to report the standard deviation. Looking down here on the equal variances assumed line, I'm ignoring Levine's test and reporting the t-value, so negative 0.28. The degrees of freedom is 291, and then my p-value, that significance metric, is p equals 0.778, so very far from that 0.05. Down here for feels part of the nonprofit, looking at the equal variances assumed, skip Levine's, go straight to the t-value. T equals 0.83, degrees of freedom is 291, and my p-value equals 0.409. So those are the metrics that you want to report, the values to report for a t-test here. So I'm going to close this out. So we're through questions 1 through 3. Let's dive into question 4. So go back over to the instructions. All right, so our favorite one here. Conduct a chi-square test that determines whether white-collar, blue-collar, or undecided volunteers were more likely to being able to commit 5 hours or more per week. And with the white-collar, blue-collar, undecided, from what I remember with this question, because ultimately up here it doesn't really say, this says individual type. I think what this was asking was whether or not the individual was volunteering to do white collar work, so office administration, database maintenance, or something like that, or was it more sort of blue collar work, general sort of office assistance, walking animals, cleaning up after them in a shelter, that sort of thing. So we're doing a chi-square, looking at the individual type here with 3 categories and whether or not they were able to commit to 5 hours or more per week. And so we've got 2 categorical variables, which is needed for chi-squares. So what I want to do here is go into analyze, go to descriptive. A chi-square is ultimately creating a cross tabulation So I want to go to my crosstabs. This is going to pull up the rows and columns. And so remember, you have to have two categorical variables. It does not matter what you put or which you put them in, a row or a column. So I'm just going to move them over in the order that they are. For my format, everything is good here. For my statistics, the key thing is to make sure that chi-square is chosen. Cells, I want the count. This is going to be the percentage for each row, column, and total. I don't really need total, but give me the row and the column. And that should be good. So let's hit OK. And here we have it. So what we first need to do is kind of report the number of people for each one. So blue collar volunteers that were able to commit 5 hours, yes, was 53, no was 39. Would also likely report the percentage there, and so need to be able to understand how that, what these numbers ultimately represent the percentages. And so what we're seeing here is that of, excuse me, the first percentage, the 57.6%, the 42.4%, that is the percentage of the row. So when I'm looking at volunteers that were of the blue collar working type, that's the type of work they were wanting to do. 57.6% of the blue collar volunteers were able to give 5 hours or more. 42.4% were not. The lower percentage here, the 32.5 and the 30, represent the column percentage. So, you know, if I were reporting of my volunteers that were able to report or were able to commit to 5 hours or more, 32.2% were blue collar, 36.8% were white collar, and 30.7% were undecided. Okay, and so I can go back and let me do that. Minimize this, go back over here. I'm going to run the same crosstab now, but this time I'm going to ask those percentages be removed. So I just get the actual number of people, and I can scroll down here to the second crosstab. So you can see they will continually add on to each other unless you close out the window. But here are those same numbers from above, just without the percentages. So let me just pause this. All right, sorry for that doorbell and interruption. I wasn't expecting that. So hit pause kind of quickly there to take care of that issue. And now let's go back and report this chi-square. So I am reporting the number, the N, for volunteers who were able to commit 5 hours and those that weren't for each of my three categories. So here I've got the simple numbers. I've got the percentages back up here that I can scroll to and just review so I can pull the appropriate percentages. But once I now want to test the chi-square, I'm going to look at the chi-square results right below it. And remember, for the chi-square test, the value that I'm reporting is based on this first line here, which is the Pearson chi-square. And so my chi-square equals 0.92, my degrees of freedom is 2, and my p-value is 0.631. So fairly high p-value, far away from the 0.05. So we know that it's not statistically significant. I can scroll down here and see that my chi-square, you know, even though I'm reporting less info as far as the percentages, my chi-square value is going to remain the same. So chi-square is 0.092, or 0.92, sorry about that. Degrees of freedom 2, and then p-value is 0.631. They do not have statistical significance. I'm going to close this out for this test result. So I think this is question 4 in the worksheet. Go back over here, and is there anything else? Okay, also need to state the null and the alternative hypothesis, which I'm going to let you do on your own. Report the number of people in each cell, which we did, and the statistical write-up. So we did that, and so you should be able to do the write-up there on your own. Our final question here, number 5, conduct a one-way ANOVA to determine whether different volunteer types, so white, blue collar, undecided, felt differently about the volunteer sessions, felt ready to volunteer after the session. So here, this is a good use of my time, and whether questions were answered. So looking at the first 3 sort of questions here, and report the mean scores, the standard deviations, as well as the statistics for the one-way ANOVA test. And so the one-way ANOVA is essentially sort of amped up t-test. The t-test, the independent sample t-test we ran, only allow you to look at 2 groups. A one-way ANOVA allows you to look at multiple groups. And so here, with our individual volunteer type, we had white collar, blue collar, and undecided. And so we got 3 groups there that we ultimately want to compare. So go back over here into my data set for this final question, and I'm going to go to Analyze. I do want to compare the means of those 3 groups, and PSPP has it nicely labeled here as one-way ANOVA, so I'm going to open that up. My factor here is my grouping variable, and that's the individual type that we have. With a one-way ANOVA, because it's not, I don't have to define the groups, it's going to do that automatically for me. And the 3 questions that I want to sort of look at were whether or not they felt ready after the session, was the session a good use of their time, and then ultimately were their questions answered. I do want to make sure I'm checking the descriptives for my one-way ANOVA, and in the contrast, I'm not doing anything with this, so don't worry with that. The one downside of PSPP at the moment is that it doesn't allow for the post hoc 2-key test to see if there were differences between blue and white collar, blue and undecided, or white and undecided, white collar and undecided voters or volunteers. So just have to work with what the program is going to give us. So everything is checked here, so let's hit OK. Look at our pop-up window here. And what I want to do is go in, report the mean and the standard deviation for each of these groups. So I would want to report that for my 92 blue-collar volunteers, they had a mean score of 7.28, a standard deviation of 1.9 in regards to feeling ready after the session. My white-collar volunteers, there were 115 of those. They felt a little slightly less prepared at 6.91 for the average, and a higher standard deviation at 2.25. My undecided volunteers, which essentially were they were open to volunteering wherever the organization wanted them. There were 86 of those individuals. They had the highest felt ready average and the lowest standard deviation score. And so what I want to then do is now look down here to the one-way ANOVA test results, and I want to report and sort of the order of this, and hopefully you can look at the PowerPoint slides to see an example of the write-up. I want to report F parentheses 2, 290, and then close the parentheses. So equals 4.28. So that's essentially saying that the F value with the degrees of freedom being 2 and 290 equals 4.28. And much like a t-test, a small f value means that it's not going to be statistically significant. The higher f values we see are statistically significant. And so here, my f value, f parentheses 2 comma 290, close the parentheses, equals 4.28, results in a significance value, a p-value of p equals 0.015. So this is definitely statistically significant. What I would want to do if the software allowed me, Jamovi will do this, but for some reason PSPP won't, I need to then go back and look up here and see what the differences really are. From this, I'm guessing that we have a difference certainly between our undecided at the highest and our white collar volunteers at the low end. But there may also be a difference statistically between the undecided and the blue collar. I can't really report that in PSPP with any certainty since it doesn't give me the option to run that test, but that's what I would want to do if I had the availability to do it. Jamovi will report it, so if you want to play with both of them, you certainly have that option, but I would write this up as best you can, speculating what the differences here may ultimately be if you only use PSPP. Likewise, with the second variable here, the sessions were a good use of my time. I'm going to report the number of respondents per category, the mean score, and the standard deviation. So just giving some basic information before I dive into testing whether those are different. I can see that all three of these averages are pretty close. So I'm going to go down to my good use of time test results and report that F parentheses 2 comma 290 close the parentheses equals 0.89 and the p-value is 0.411. So essentially what we're saying here is that my F value for the degrees of freedom 2 comma 290 equals 0.89, so we have a fairly small F value, and that's going to result in a statistically significant number that is much higher than our number of 0.05. So we do not have statistically significant results here. Our last one, I'm going to report my categories with the number of respondents for each group, the mean score, as well as that standard deviation for all three of them. And then I'm also going to jump down here to report my F value, which is 4.31. Make sure to include the degrees of freedom, the 2 comma 290. And then also my significance value. And here is another statistically significant finding. And so go back up here to speculate, and clearly it kind of looks like it's going to be between white collar and undecided volunteers once again. Okay, and so that, let me just close this out here. Go back to the instructions to make sure that that is all that they're asking for here, or all that I'm asking for in this report. And so that is it. So I'm going to stop the recording now. You've got the sort of ability to go back and look at this video, look at the numbers that I've pulled from the file to be able to check your own work. I'm going to see if I can actually upload this to YouTube and not just relieve it here in the Zoom platform, so that ultimately when you move forward into your capstone or into other work that you may do professionally, you could come back and check this out and just see the steps that I used over in PSPP to get the data to be able to interpret. So hope that was helpful for you. I'm going to stop the recording now and look forward to seeing you in class on Thursday. Bye.